Alright, in this tutorial, I'm going to talk to you about divisibility rules, and these are just rules to help you determine if a number is divisible by some other given number. So I have a list of very common ones that are going to help speed the process up of finding divisibility. A couple ones that I left out on purpose. For example, number 1 is not on there because every single number is divisible by 1. It's always going to be a factor of everything. 7 and 8 are not on there because they're a little bit more complicated than the rest. The whole point of using divisibility rules is to kind of quickly assess what some factors are or whether a number is divisible by something. And 7 and 8 are just not worth the amount of time it takes to figure out if something is divisible. Now, if you start to get more comfortable with these numbers and you want to explore 7 and 8, go right ahead. But for right now, we're going to start with number 2 is going to be divisible into any other number if the last digit is even. Okay, so remember your single digit even numbers are going to be 2, 4, 6, 8, and 0. So if it ends in one of those 5 digits, the entire digit is going to be divisible by 2. For number 3, this one's kind of interesting. You're going to take the sum of all of your digits, add all of them together, and if that sum is divisible by 3, then your entire original number is also divisible by 3. Okay? Whatever resulting answer you get, if that number is divisible by 3, then the entire original number is. It's just kind of a way to reduce to figure out what numbers are divisible into 3. For number 4, the last 2 digits are divisible by 4. Okay, so if you have a number that ends in 20, 24, 36, 40, then the entire original number is divisible by 4. Number 5, last digit is either a 0 or a 5. If it ends in one of those two numbers, then that original number is going to be divisible by 5. Number 6, we're going to kind of combine two previous rules that we've mentioned earlier. You're going to follow the rules of both 2 and 3 at the same time. Two and 3. So your number must both be even and its total be divisible by 3. Since 6, in order to get those factors, are 2 and 3, you have to follow the factors of both 2 and 3. For number 9, it's going to be very similar to number 3. You're going to take the sum, and as long as that is divisible, instead this time by 3, it's going to be divisible by 9. Okay, so 9, 18, 27, 36, etc. If you get that as a resulting answer, then the entire original number is going to be divisible by 9. For number 10, the last digit is 0. Okay, anything that ends in 0 is always divisible by 10. Extra zeros include the extra zeros of the divisible numbers. So if you have a number ending in 2 zeros, you can divide it by 100 since it ends in 2 zeros. So let's check and see with these 3 very large and random numbers to check and see if they're divisible by these. So 2,799,588, if it's divisible by 3. Well, our rule for 3 earlier was that if the sum is divisible by 3. So we got to take all of these numbers and add them all together. So we're going to take 2, 7, 9, 9, 5, 8, and 8, and add them all together. 2 plus 7 is 9. We have this 9 plus these 2 9s is going to give us 27. 5 and 8 is 13, plus 8 is 21. Remember, you can add any digits in any order, so it does not matter. If you want to start combining these 8s and 9s together to get those reduced, that's fine. 27 and 21 give you 48. Now I can tell right here, just by looking at it, that the number 48 is divisible by 3, because I'm familiar with my factors. But if you need to keep reducing and take 4 plus 8 to get 12, hopefully from there you can see that 12 is a factor or divisible into 3. If you need to keep adding those two together, 1 plus 2 is 3, and since that 3 is a number that we are ending with and it's divisible by 3, then yes, the number 2,799,588 is divisible by 3. Now let's check the next one, 5,670 divisible by 4. Well, the rule for 4 is to look at the last two digits, 70. Now the last digit is even, so the entire number is divisible by 2, but for 4 we have to check the last two digits combined. Now I know that 4 goes into 40, 4 goes into 60, 4 goes into 80, but it does not go into 70, so no, this number is not divisible by 4. Okay, 4 goes into 60, and then it goes into 64, 68, 72, so it skips over the 70. Last one, 100,765 divisible by 2. 2 is the easy one. You just look at the last digit and check and see if it's even. The number 5 obviously is not even, so no, 100,765 is not divisible by 2.